Hello everyone, welcome to another interesting project series with Date with Data. In this project series, we are going to implement end-to-end data engineering project using various AWS cloud services and Apache Kafka. Let's now go ahead and look at project architecture. This is the overall architecture that we'll be setting up throughout this video series. We have a producer application running in EC2 instance that will write data to specific topic of Apache Kafka. Then we'll have a consumer application that will read a data from Kafka topic. All these events will be monitored using AWS CloudWatch. When our consumer application reads a data, it takes the data from Kafka topic and write it to staging layer of S3, which is also known as raw layer. Now, once our data is present in staging layer, we'll run a glue ETL periodically and merge the data to a data lake. That is also a S3 bucket. Now, since we have a data lake, we need some querying tool that by using which we can query a data present in data lake. For that, we have AWS Glue Crawler. Glue will create a table and databases out of the data present in data lake. Once our database and table is ready, we can make use of AWS Athena to query a data present in data lake. The major focus in this project is learning how to make use of Apache Kafka to read and write to specific topic and understand what is Kafka partitions as well. Apache Kafka is super efficient messenger that helps different part of big system communicate. It helps us to decouple producer and consumer application, and it helps them to run independently. Kafka is really good at handling lots of messages quickly and making sure that they goes where they need to go. Kafka helps business manage and process huge amount of data in real time, making sure everything runs smoothly and efficiently. Kafka also makes sure our system remains fault tolerant and are highly scalable. We'll be understanding about Kafka broker, partitions, topics, etc. in our upcoming videos. For setting up this project, we need to first set up our Kafka cluster or a Kafka broker. Once our Kafka cluster will be set up, we'll be trying to run a consumer and producer application from our local environment. We'll see whether we are able to write to a Kafka cluster or not. Once our environment for Kafka is set up, we'll try to make use of AWS Cloud and create our producer and consumer application. Then we'll create our Glue ETL jobs. Before going ahead with setting our project, let's understand the dataset that we are going to be using in this project. Since building a real world system is really tough, we are going to be using a data in Kaggle. It is just a replica of a data that is going to be used in a modern applications. Spotify data is the data provided by Spotify. This dataset consists of 5 CSV files named albums, artists, Spotify data 2023, features and tracks. The amount of data is fairly large of around almost 99 MB, 2.51 MB, 212 MB and so on. The data is quite unclean, so I have little bit done a basic pre-processing and provide a clean format for it for this data. I'll be attaching the data in the description of the video. After cleaning the data, we have come up with 3 CSV files. They are albums, artists and tracks. Now let's go ahead and start creating the project. We'll first set up a Kafka cluster, then our AWS setup. Hello everyone. In this video, we'll create a Kafka cluster. To create a Kafka cluster, we'll be using Upstash. Upstash is designed for serverless with per request pricing for Redis and Kafka API. It works for all the common use cases of Redis and Kafka. So using Upstash, we can manage our Kafka broker, topics, etc. To create a Upstash account, go to console.upstash.com and log in using your mail account. Once you log in, you will land in this page. Click on Kafka. To create a cluster, click on Create Cluster. Now you need to provide a cluster name. Let's say Demo Cluster. Now you can select a region of your choice. You can also select single replica or multi-replica cluster. Since we are in free tier, let's select single replica only. Now we can see that our cluster is set up and we need to create our first topic. Let's name it topic 1. Now we have something called partition count. Partition help us to create parallelism in our Kafka server. We can provide any number of partition, but since this project is very small, let's keep 1 as a partition count. When we create for our project usage, we'll increase the partition count. And there is some advanced configuration as well, like cleanup policy, retention time, retention size, max message size, and so on. For this project, let's leave everything as default. Now go ahead and click on create topic. Now our topic is ready, and now we can see the endpoint for our broker application. This is the endpoint for our broker application. This is the username and password. We can connect to our cluster by connecting to the broker endpoint. We can connect using various programming languages like Java, Node, Python, Go, C#, and so on. For this project, we'll be making use of Python. In Python, we need some built-in library to connect to Kafka cluster. There are 2 libraries using which we can connect to Kafka cluster. For this project, we'll be using Kafka Python. When you click on that link, you will land up in a GitHub page. And there is a documentation provided for this. Using these scripts, we can connect to our Kafka producer and consumer application. There is also a steps to serialize the data. In a later section of this course, we'll see how we can connect using Python. There is also REST API endpoints provided and webhook as well. As of now, we are in a free tier and we have a limitations. If we want to increase, we need to go for pay-as-you-go model. For this project, free tier is enough. This gives the usage. Once we start producing the data in our cluster, we'll see the usage and usage metrics and so on. When I go to topics, we can see that as of now we have only one topic, that is topic 1. We can also change the configuration from here. This is the credential section. This is the connectors. We can connect to Kafka broker using various connectors. And this is the schema registry. Now let's go ahead and write a Python script to connect to this producer and read the data for using a consumer application. Now let's copy the producer code. We have created a IPONV file. When you paste the script from there to here, now whatever we want to produce or whatever we want to write to our topic can be written here. That can be passed here as a string or any object. We need to provide a topic name here. For our project, a topic is named as topic 1. So as per the requirement, you can paste a topic 1. Now as of now, I am producing welcome to YouTube 3. Now we can see that our message is successfully produced. Same way, let's do YT2, YT1. Like this, we have produced 3 data points to our topic. Now our topic which we have created have 3 files here. Now we can connect to the topic using our consumer application. To get a code for consumer, go here and copy this code and paste it here. Now this will help us to connect to our topic. Our topic is named as topic 1. Rename here to topic 1. Now our consumer API will connect to the topic 1 and it will start reading data from here. It will go on pinging our consumer node until it have received all data, and it will keep on pinging even after that. It will keep on pinging consumer application, and whenever new data points arrive in our topic, it will read it. Now if I run, we remember we have produced YT1, YT2 and YT3, YT2 and YT1. Now let's see the data. Now we can see that YT3, YT2 and YT1 is produced in the same order, and we can see that it's still running. It is still running because it is going on pinging the topic, and it is, since it have not found any new record, it is just running. If we run our producer application again, it will again fetch a new data points. Since we are using only one partition, hence our order of the data points is maintained. Order is always maintained within partition in any topic. Now we'll start writing a Python script to write a data into 3 different topics. We'll first create 3 topics named albums, artists and tracks, and we'll write 3 producer application that will write to 3 different topics, and then we'll create 3 consumer application that will consume data from these topics. Now let's go ahead and implement that. Now let's go ahead and create 3 topics as per our requirement. We need 3 topics named albums, artists and tracks. Let's go to topics. Let's delete the old topic. Let's create topic named albums. We can increase number of partition to 3. Rest we can just leave it as default. We can increase this to 3. Next is artist. Now let's increase this to 3. Now we have successfully created 3 topics with 3 partition each. We have retention time as 7 days, retention size is 256 MB. Now let's go ahead and write a Python application that will read data from CSV file and write it to our respective topics. I have already written the scripts. We'll go and see the scripts once. Now we can copy this, paste it here. Now what we are gonna do, we first import Kafka, producer, pandas library and JSON. Then we connect to our producer API. We read a CSV file using pandas library. Now we'll parse each data points that is present inside track.csv. Our track.csv file has around 4,38,000 records. So we'll go through each record and we'll convert that record into a JSON type once, and we'll encode it into UTF-8. Once we have converted into JSON type, we can send to our respective producer. It is tracks and not producer topics. We have a tracks topic here. So it will connect to that producer and it will go on sending the message. and we'll write message produced. That is gonna be our producer application. That is very simple. Next, let's go ahead and see a consumer application. Now let's understand what our consumer is doing. Our consumer is reading data from Kafka topic and writing it into a staging layer of our S3. So now let's see. Now for that we need to import consumer library, pandas, JSON. We'll see why we are using random and string. We are using Boto3. We need Boto3 because our EC2 instance need to write data to S3. So we need to connect to a S3 client. So for that we need Boto3. We'll see why we are using generate random string. First we connect to our consumer API, then we use S3 client. This is our bucket name. Whatever bucket name we have, we can provide it here. Now we have our data list. So what we are gonna do, we are gonna read data from a producer application. Now it will go on pinging the consumer API, and once data is read, it will append it into a data list. Then we'll read data in batch of 10. Once we have 10 data points inside our data list, it will convert that into a data frame. Then it will write that CSV file to the buffer, and it will now create a file name. Since we need to write many files, we need to generate some random names. For that we are using generate random string. It will take length as a parameter, and it will generate a string of length random string. So basically that will give us a S3 key. Inside our S3 bucket named DE project Kafka, we'll be having a staging folder wherein we are gonna write this CSV file, and S3 client.put object is helping us to write that to our S3 bucket. Then we'll print we have successfully uploaded. Now our consumer application will be always running and will write the data to our S3 bucket. So this is how our consumer is gonna work. So let's copy this code for all three topics, that is albums, artists, and so on. So let's copy the producer code to artist producer. The topic that we are gonna use is artist. The CSV file that we are gonna use is artists.csv. Right, the topic name is artist.csv, and that is all right. Now let's copy this again and write to albums. The topic name that we are gonna use is albums. And the file name that we are gonna use is albums.csv. That is our producer.py file. Now let's go to consumer.py file, copy this, go to consumer.py of artist, paste it here. Now the topic name is artist. We need to connect to this. We will write into, now we need 3 folders, right? So we need inside staging, we also need artist folder, because we need to differentiate which consumer is writing where. So staging/artist, copy this. Now we'll go to this consumer, it is albums. This is correct. Now we need to put here also albums, right? Everything else is all right. Now that our producer and consumer applications are ready, we are gonna now create S3 bucket. Then we'll create a EC2 instance and host our consumer and producer applications there. Let's now go ahead and create EC2 instance and S3 bucket. Let's first create our S3 bucket. Go to S3, click on create bucket. We need to provide our bucket name that we have taken as DE project Kafka. Let's see if it is available. Let's leave everything as default and click on create bucket. Our bucket is successfully created. Now let's go inside bucket. When we see our architecture, we have two layers, that is staging layer and data lake. We can create two different buckets for this, one as staging bucket, another is data lake bucket, or otherwise inside this single bucket we can create two folders named staging and data lake. Let's do that. Let's name staging. Now next let's name data lake. Now since we have three topics, one named albums, that is staging / albums, another named artist, and another named tracks. Now create three folders: albums, artist, and tracks. Now our three consumer application will write to each of these folders. One is tracks, another is artist, next is our albums. Now our S3 bucket is ready. Let's now go ahead and create our EC2 instance. To create EC2 instance, search for EC2. Now to create an instance, click on launch instance. We can provide the name for our instance, that is, let's give it name as producer. We can use Linux AMI, and our architecture we can leave it as default, and our instance type we can use T2 micro as it is free tier eligible. So now we need a key pair, that is to connect our EC2 instance from our local we need a key pair. Since we need to transfer our files from our local to EC2 instance, we'll be requiring key pair to make a SCP request. Let's create a key pair. Let's create a new key pair. Let's say project. Click on create key pair. The key pair will be downloaded. It will be named as project.pem. Now we need to set up our security group, that is security group help us to make any connection to our EC2 instance. Since we need SSH connection to connect from local to our EC2 instance, we need to allow SSH traffic from anywhere. We don't need HTTP and HTTPS because we are not hosting any website, so we can just leave it as default. Our storage is 8 GB, that is enough for us. Number of instances 1. Let's go ahead and launch instance. Now our instance is ready. We can go here. It will take little bit of time for the connect to appear. We can see the VPC, subnets, and so on. We also have got public IPv4. Now to connect, there are different ways to connect to our EC2 instance. One using PEM file, another using SSH client, another using EC2 instance connect. If we are using EC2 instance connect, we can directly in a browser launch a terminal and start running our code. But for this project, we'll be connecting by a SSH client because we need to transfer data from our local to our EC2 instance. I have created one dedicated video for transferring data from local to EC2 instance. You can go ahead and check it out. So we'll be now connecting to our EC2 instance using SSH client and hosting our Kafka application here, hosting our production and consumer applications here. Now to copy data from our local to EC2, let's start a new terminal. I have copied .pm file from my download folder to the project directory. To do that, we need to use scp command and copy this code. Right, we need scp, paste this. Now post this, we need to provide a path of our local directory, path of our source, that is present working directory, pwd. We can do, we got a path, we can copy this and paste it here. Next, I need to provide a path for my ec2 instance. I can go to my ec2 instance. I want to paste it here, so if I do ls, I should see the code, so I can paste it here. Now since I need to copy all the files, that is I need to copy all the folders, I can go ahead and do -r. I don't need env file, that is very big, that is just an environment, so let me just delete as of now. So now I can just paste -r, press enter. Now there is no file or directory, it says. That is our local path. Okay, sorry, I should have copied this. This is my ec2 path, and before this ec2 instance I should paste it here. I should paste it here. No. Now we can see that all my files are copied from my local to ec2 instance. Now if I just do my ls, I can see that project directory is here, cd project. If I just do ls now, I can see that my ppt file, connect file, tracks, all the folder is getting copied one by one. I don't know why are so many files getting populated. It is just because of those csv files. We have quite big csv files, so it is taking time. Now like this, all my data from my local will be copied to our ec2 instance. Now in our project, our ec2 instance is trying to write data to our staging layer. So our ec2 instance must have access to s3 bucket. So for that we need to create IAM role. Let's go to our IAM. Let's go to roles. Let's go ahead and create role. What is the service we are using? We are using ec2 service, right? I can go to next. What access we need? We need s3 access. So as of now I can just give s3 full access. Now let's go to next. Let's go ahead and create role. I should provide a role name, that is, let's say project de role. Now let's go ahead and create role. Now I can see that my role is successfully created. Now I need to go to my ec2 instance and attach this role to the ec2 instance. Let's go to the instance. Now if I just go here and if I just go instance setting, I can go to this security. Yeah, in security I can see modify IAM role, and I can choose my IAM role, that is project DE role. Click on update role. Now my ec2 instance will be able to write data to my s3 bucket. Now it will take some time to copy data from local to ec2 because our csv file is quite big in size. So let's wait. I'll join the session once my data is successfully copied. Now that we have copied our file from local to ec2 instance, now we can start running our application. First we need to go ahead and install Python. To do that, let's first do sudo yum update. Now to install Python, sudo yum install Python. Now this will install Python. I have already installed, so I am saying dependency resolved. After that, we need to install pip. Pip is a package manager. It will help us to install Kafka in our EC2 instance. Sudo yum install python 3 pip. This will install the pip. Now once my pip is installed, I can go ahead and install pip install all the required dependencies. First, let's install pandas. Once pandas is installed, let's install Kafka Python. Now our Kafka is also installed. The next dependency that we need to install is pip install boto 3. Now once our all dependencies are installed, we can go ahead and run our producer application. We have 3 producers, so one is tracks, artists and albums. We can start with tracks. To run our producer application, we can just do python producer.py. Now we can see that it has started writing to a topic named tracks. Now we can also start our consumer application. Go inside tracks. Now let's do python consumer.py. For starting a consumer application, I have started another instance connect so that I can demonstrate at the same time it is producing and at the same time it is consuming the application. Now we can see that data frame uploaded successfully. It has started consuming and writing to our S3 bucket. To see whether it has started writing to our S3 bucket or not, we can go to AWS console, go to S3, go to our buckets. The internet is slow. Go to our bucket, and inside bucket let's go to staging layer and let's go to our tracks. I can see that it has started writing .csv files, and we can see that it has already written 47 CSV files and still continuing to write. We can go here and we can see that it's consuming, and at the same time our producer application is also running. We can create a different EC2 instance for our different topics or different producer application, but since we are doing this project for demonstration purpose, we can create a many instance connect. But in a production grade application, you may need to create different EC2 instance for each topics, or maybe in your real-time scenario, your application itself will be writing into different topics. Here we are having 3 CSV file, we are reading from CSV file, but in real world application it will not be like that. It is just a replica. Now let's go to my EC2 instance. Let's go to EC2. Internet is bit slow, so it's taking time to load. Once we reach EC2, I can connect. Right now we can launch more instance connect. Right, and we can run our other producer application. Like, let's go inside project. Right now I can do my albums, python producer.py. Same way I can run my other producer application, right? cd Tracks is over, albums is over. Let's go to artist. Python producer.py. Now my artist application is also started to produce. There is no art. Oh, ATISTS. I can rename it. Now let's start my producer application. Now I can see that all my producer have started producing data. Now I can also start my consumer application mode, like two more consumers. Like same way I can connect to my albums, cd albums, and I can do python consumer.py. Right, now my consumer app also started for topic albums. Now we can see that it has started writing to our staging layer of albums. Same way I can go ahead and start my artist topic consumer.py. Now in some time it will also start consuming my data. Now we can see that our consumer have started working. So I can see that all my producer are producing the data, right? And my consumer application is writing a data, right? So when I go to my S3 bucket now, when I go to my S3 staging layer, I can see that all my data is populated here, right? My consumer have successfully returned data to my S3 buckets, that is staging layer. So this is how we can create a producer application and a consumer application and integrate them to read data from specific topic they want. Now we have brought our data to our staging layer. Now next step is our glue will run that will take a data from staging layer and write it into a data lake. So I know, like, as of now we are reading from CSV file, so these steps will not be running 24/7, but in a real world this step will be running 24/7 and a data will keep on coming in our staging layer. Now let's go ahead and create our glue ETL that takes data from staging layer and writes into a data lake. Now that our consumer application has successfully written all the files in our S3 bucket, we can close our consumer application. But in a real world, our consumer application will be always alive and it will take a data and write it into a specific topic from the producer, whatever it writes, right? Whatever your producer writes, it will go and write into a specific topic. And your consumer will be always alive and it will keep reading data from your Kafka topic. But since we have very limited amount of data, we can close our consumer application as of now. So now our data is ready in our staging layer inside our albums, artists and tracks. Now we need to take this data from staging layer to data lake. We could have directly run a glue crawler in our staging layer and started consuming it through Athena, but what problem it causes is we have small files, right? When our consumer application will keep on writing to our albums, this small file will be large in number. In a day, now when you are running, we can see 100 files. When you are running for a whole day, it will create thousands or lakhs of files, right? So we cannot do this. We have so many small files because our Athena will not be able to read such small files. Hence what we do, we take all this data from staging layer and write it into our data lake. We can partition it there. We can partition by date. Let's say today's data will be written in one folder, then tomorrow's data will be written in another partition. We can do that, but since we are doing for only one day, I will not be creating partitions. Now we can do many other things as well. We can read a data from albums, artists and tracks, and we can create one big table, right? Otherwise we can create three different tables, one for albums, artists and tracks, right? But for this project we'll be creating one big table. We'll take a data from all these three, join it and write it into our S3 data lake, that is here. Okay, now let's go ahead and start our glue. Bucket, let's go to glue. To start creating our ETL job, we can create a visual ETL, right? Now visual ETL is a recent feature which AWS Glue have launched. Herein we can just drag and drop and create our ETL pipeline. So we have raw S3. Let's read tracks data from here, right? Our browse S3, we can go to our staging layer and we can go to my tracks and choose. Now we can just do CSV file, and now I can see that we have to assign a IAM role first before viewing, because we need to give access or glue the EC2 access, right? So what do we need to do? We have already created one role, but that is for EC2 instance, but for now I need for glue. So let's go to IAM. Let's go to roles. Let's go to create roles. We need to choose glue, right? Now next I need to search for S3. I can provide S3 full access. Now this glue to S3, right? This way we will be able to create our IAM role. Now if I go to AWS Glue and now search, no roles available. We need to refresh a page. Let's refresh it. Source AWS S3. Let's do for tracks. Let's browse the data that is there in staging layer, tracks, right? Now our format is CSV, right? We need to provide an IAM role. I can see glue to S3 here. Now we can see that it has started seeing the data and it will give a preview of the data whatever is present. Now we have data in three layers. One is tracks, one is albums, another is artist, right? So inside staging I have albums, artist and tracks. So we need to create three sources here. Let's create one more source and one more, right? Here I can give artist. Let's I can browse staging. I can provide a path as artist, then format to CSV. It have started filtering the data. Same way let's do it for, we have done for tracks, artist, albums. Let's go to browse S3. Let's go here, let's go here, and albums. Let's choose CSV. Now all our three sources are ready. I can see the data here. It is still reading because there are lots of small files. It is taking time. So now what do we need to do? We need to join these two tables, right? So what do we do? We add here. We have a transformation. We need to join. So what all tables we need to join? We need to join these two tables. Let's copy it here. Now we need one more join, right? So what all we'll join? We'll join this table and whatever we have got from here, right? This way we'll perform a join. Now once our join is done, we will write our data to our S3 bucket, right? Now this is all my ETL will look like, right? So let's see whether our data is ready or not. I can see my data is ready. It has successfully read track ID and track popularity. Same way for artist, it has got ID, name, artist popularity and follower and so on. Okay, now we have done one mistake, that is albums must be here and artist must be here, because albums and tracks have a track ID, right? So to do that, let's change the path. Let's set it to artist and change this name to artist, right? And change this to albums and change this name to albums. Now we can go to our join condition. We can add a condition. From tracks we need track ID, from albums we need, I guess it has not still read the data properly. It is still reading the data. Let's wait for some time. Albums, yeah. And now custom prefix inner join albums as track ID, right? So track ID from tracks table and track ID from albums table will create a join. Now we have inner join add condition. From artist table we have artist ID. Join here also will be a artist table, artist ID. Now after join, we have a S3, but we need to do something else. One more. Let's delete this as of now, right? When we are joining here, we can see there are some unnecessary column name which have been created, that is dot track ID and all. Let's go ahead and remove that. Transformation, there must be somewhere drop fields. Yeah, we have drop fields. Let's go ahead and drop dot track ID, and this also we can drop. I guess this ID is what? This ID is used to represent our artist ID, and yeah, correct. Now we already have artist ID, so I don't need this ID. This is same as artist ID. All the other things is important. Now what we can do, we can write this data to our S3 bucket. That is, we can point this to S3. This is why it's not getting pointed. Oh sorry, this is a source. We need to create a destination bucket. Target S3 target, sorry. Now we can copy this and write it to here. Now we need to provide a path for our S3. I can go to data lake and just put the data here, right? Now we can choose the format in which we want to write a data. Since this is used for analytical purpose, we can make use of Parquet. So let's write job. Now I can save this. Now we have got a visual ETL, right? Now if you need some complex transformation all, we can also make use of script. See what visual ETL basically does, it will help us to create a script without actually coding it, right? It's making our things easy. But if you need to do some complex transformation and all, we may need to edit the script. So visual ETL is only available in the beginning stage. Once your first stage is done, post that you will not be able to make changes using a visual ETL. Now if I save, Now our job is successfully saved. Now I can run the job. Now to check our job monitor, I can go to job runs. I can see the runs. Now I can see that it is running. So you can also change your job detail. As of now, it has automatically fetched Python 3, the worker type, all these things it has successfully fetched, and it has assigned a number of workers as 10. That is the default number of workers. You can change as per your wish. Job time what is set to 2880 minutes. Now we can, the ETL will run for some time. It will take some time to run. Now our ETL have run successfully. We can monitor the logs from here, and we can also see the metrics and all, like how much it have done a read and how much data shuffle have happened. We can monitor from here. Since our job have run just for 2 minutes, our data size was very small, so not much of our metrics have been populated. But when you have a huge job that runs for half an hour or 1 hour, in that case you will be able to see the CPU load, everything, how each executor have run, right? All those details you can see. Now let's go ahead and see in our S3 bucket whether our data have been available or not. Yeah, let's go to our data lake, and now we can see that our Parquet file has been there, like has populated there, and I have 36 Parquet files, right? Now if you just want to understand the script, let's go ahead. Okay, now what it does, it first creates a glue context, like Spark context. It creates the glue context, right? Glue have some advanced features apart from Spark, like glue dynamic frame with options, resolve options, and so on. So now post that, since all this code have been automatically generated, it has written down lots of things, right? Now it have created tracks node that reads the data from this path, that is S3 DE project Kafka staging tracks. Then same way it reads data from albums, then artist. Next is our join. Now it have joined our tracks and albums module first, then next have joined our artist and join node, this one, right? Whatever is joined, that result is joined again. Now unnecessary codes have been dropped, and post that it has returned to our S3 bucket, that is our data lake, right? So this is our overall Pyspark code that has been populated from using AWS Glue. Now our data is here, right? We need something to query this data. So for that we'll be using AWS Athena service, right? Now let's go ahead in Athena. Now when you go to Athena, we can see that as of now I don't have any database available. So to create a database, I need to run a glue crawler to create a database and tables, right? So now let's go to AWS Glue again, right? In AWS Glue, I have a section called data catalog, and here I can create my databases and tables. Now let's create a database. Let's name it DL. Now our database is successfully created. To create a table, we don't manually create our table, define schema and so on. We can do that if we want, but we can directly run a crawler. Let's click on create crawler and name some crawler name, may it be project. Now let's go to next. Now we can provide our data source. I can browse my source, I can go here, I can just make a data lake. Now I can go to choose, and now I can crawl all the subfolders that are there. I can also do sample subset of files because the schema across all the files remain same. So I can add an S3 data source. Now it will crawl this and create a table out of it. Now let's go to next. Now I need to provide IAM role. What IAM role we need to provide? We need to allow Glue to access S3. Same IAM role we have already created once, right? So we can make use of same IAM role. Now let's go ahead and click next. I can provide a table name. If we are not providing any table name, it will read the same as the folder name. It is our data lake, so we are fine with that. Now we need to choose a database. We are creating a DL. So tables will reside inside our database. We have already created our database, so we can choose I want to put it inside a DL database. Now I can go to next, right? Yeah, before this, we can schedule our crawler as well, like we can do on demand, daily, hourly. So whenever new data comes, we can run a crawler. So if ever there is some update that have happened in a schema, it will automatically update the table schema as well. So that also can be done using this custom crawler schedule. As of now, we need to run only once, so I can click on demand. Now next, go to next. Now I can go to create crawler. Now our crawler have successfully been created. Let's go ahead and run our crawler. Now my crawler have started running. So we can see that our crawler have failed and it have given an error message saying AWS Glue does not have a put log events, that is log. So what the problem is, we have only given it access to write into S3, right? We also need to give it to write to CloudWatch. So for that reason it has given us error. Let's go to IAM role, right? If I go to IAM, let's go to roles, let's go to glue to S3, let's add few more policies, right? Let's give it an administrator access. You can also give a CloudWatch access, but let's just to be in a safer side, we can give administrator access. In a real world project, you must always avoid giving administrator access. You should also only give a required access. You should also not give a S3 full access. You should give very refined access to the services. Now once that is done, we can run the crawler again. Now we can see that our crawler have run been successfully run, and it have shown the status is completed. Now let's go to our glue. Now if I go to database, I go inside DL, I can see that a table named data lake have been successfully created. Now if I go to my Athena service once again and refresh this page, right, now I can see that my data lake has been successfully created and I can preview data from here. I'm getting an error saying output location is either through workgroup, result, configuration, through setting version API. So I'm not able to run. Okay, why I am not able to run is, okay, saved queries, editor. Okay, now I need to edit the settings. Why? Now whatever is the query result, right, I need to write it somewhere in my S3 bucket. Now whatever query we do, so we need to create one folder inside my S3 for writing my Athena results. Now let's go to my S3 Kafka. Now let's create a folder named Athena. Now when I go here, I can browse my S3. I can go here, I can click this. Now if I save, now I can save, right? When you do this, when you come here, now I can see that my run is successfully, I can run this code. My run have turned into orange. Now if I run, I can see that I can read the data from here, right? I have followers, artist ID, and so on. Okay, I can just do now artist ID comma name, track name, right? Now I can see which artist have sung which track. So like this, I can query any amount of data and I can query and do analysis using this data. So by doing this, we have successfully completed our overall project. What we have done, let's go through each one of them one by one. We have created a producer application and written a data to our Kafka topic. Then we have created a consumer application that takes data from Kafka topic and writes it into a staging layer. Once that is done, we used a glue crawler. Why did we use? We could have done even in staging layer. We used because of small file problem. Then it have taken data from staging layer and written it into a data lake. Then we have made use of AWS Glue Crawler that creates a table. Then we have made use of AWS Athena for a analysis purpose. Thank you for being with me till the end of the project. Thank you. Now that we have created our project successfully, let's go ahead and delete all the AWS services so that we don't start incurring a lot of cost. So for doing that, let's go to each of the services that we have created one by one. And let's go to my AWS console. What's happening? Okay. Okay, let's go inside my S3 bucket. Let's delete it. Let's type permanently delete permanently. Now let's go ahead and delete the bucket. Copy the bucket name, delete. Now our bucket is successfully deleted. Next thing that we need to delete is this glue. Delete. It's not empty. Let's empty the bucket first. I can type. Okay. Exit. Now I can delete this bucket as well. This bucket was by default created by AWS Glue. Whenever we ran the glue crawler or whenever we ran our glue job, it will save all its scripts here. Now let's go to our EC2 instance and stop that instance as well. Why AWS is giving some problem today? Now let's go ahead and terminate our EC2 instance. Let's go to instances and I can go here and terminate my instance. Now my EC2 instance is deleted, S3 is deleted. Next thing is AWS Glue. I can go to Visual ETLs. I can take this job, action, and delete job. It will delete the job. Now let's go to my crawlers. Now I can go here, delete the crawler as well. Now let's go to databases. Click here, delete my database as well. Now we have removed everything from AWS. We also have IAM roles, but that's not necessary to delete. Then let's go to my Upstash and delete the cluster. To delete a cluster, go to the details and go to the bottommost. Click on delete cluster and provide a cluster name, that is demo cluster. Click on delete cluster. This way I have deleted whole setup from AWS and Upstash. Now let's understand a little bit shortcomings or like what you can implement on top of all this, right? On top of all this, you can also handle incremental load. As of now, whatever data is present in staging layer, we used to directly take it into data lake, right? Whenever new data comes, right, after half an hour and 1 hour, new data comes to staging layer, we have not done anything to handle that scenario, right? In that case, you need to create partitions, or you can also do incremental load, like you can take data from data lake and append the data that is coming from staging layer. You can also do that. You can try implementing all these approaches. So this is one thing that you can improve on top of all this project. Thank you. What if you are able to create incremental load, do comment, do provide comment and share your code in the comment section. Thank you.